Hello scale modelers! In this video I'm building a large display cabinet or vitrine to display some of my finished models. So make yourselves comfortable because we need to cover a ton of stuff about woodworking, painting and electronics. So while some of you might have to work in the kitchen, I have been fortunate enough to have my own space and desk for hobby projects. And for a long time I've been thinking of building a large vitrine hanging above my workspace to display finished models and things I have collected over the years. Looking at some of my models and future builds, I think spaces of 15 cm high and about 5 shelves would be the best setup for me. I like these long shelves, but I'm worried they will sag over time, so instead I'm adding a vertical wall in the middle for support. With the shelves cut in half, I can also put some variation in the height of the shelves. The top shelf on the right will be used to display the largest models. Finally, the plan is to lit the models with LED lighting and keep them free from dust with sliding glass doors. After taking some measurements and sketching, I turned my ideas into actual plans. The project will be made of MDF because it's easy to work with and it's still relatively cheap compared to some other wood products. I did my best to make the whole project out of one sheet of MDF, but still a leftover piece was needed for the last shelf. I went to the local hardware store and bought a sheet of 18 and 12mm MDF, which they cut to a transportable size for me so it would fit inside the car. At home I started to rough cut these panels even further. For this you can use a handsaw or lay down a sheet of styrofoam and cut the panels onto that with a circular saw. If you have a table saw, you can save a lot of time making the parallel cuts for all the shelves and side panels. These things are handy but also dangerous, so don't rush things and use safety gear. If you don't own a table saw, then perhaps someone in the family or neighborhood can help you out. My table saw is too small for making 90-degree cross cuts on these long panels. So I made a handy jig which allows me to create square cuts with a circular saw. It uses two boards screwed together at a 90-degree angle and a piece of aluminum to guide the saw. I align the jig with the cutting line and then do a pass with the saw blade to make a clean crosscut. Next I turn over the panel, measure the length of the shelf and mark it down. I then use a square to mark the cutting line, align my jig and cut the shelf to length. It's important to regularly check that things are still accurate. After a bunch of cutting, all the panels are cut down to size. Next I lowered the blade of the table saw to make fine grooves into the side panels. I made a total of 3 passes to end up with a groove of about 7mm wide. These channels will later be used to install the electronic wiring for the lighting, but more about that later. Next I marked out the location of each shelf onto the vertical walls of the cabinet. I also drew a small centerline to position the screw holes. Then I started pre-drilling with a small drill bit. Next I turned the panel on the other side and all the rough exit holes are removed with a countersink bit. Back on the vertical sides I did the same thing, countersinking holes so the head of the screw will be underneath the surface. The vertical panel in the middle needs some extra attention, because this panel supports shelves on both sides. So only the shelves on one side needs countersinking, while the other holes are countersunk on the back side. So after all that countersink drama, it's time to glue some things together. Let's start off with the corners of the cabinet. I added some wood glue to the joints and then lined up both pieces. I made sure things were square, and you can skip this step, but a small nail gun can be helpful to hold the pieces in place while you're pre-drilling the screw holes. Pre-drilling is done with the same diameter as the inner body of the screw, because without pre-drilling the MDF might split. In this case I'm also using a larger drill equal to the outside diameter of the screw, but only 18mm deep, the thickness of the first panel. This will make sure that the screws pull both panels strongly together. Next I added the screws. And last but not least, I tap in the nails because my small nail gun didn't have the power to do so. So I screwed the 4 corners together and started adding the shelves on the left side. So again I added wood glue, put in 2 nails, pre-drilled the holes with a small drill bit, pre-drilled the first panel with a larger drill bit, and then added 2 screws. Next I mounted the vertical panel in the middle, and then installed the shelves on the right side. With everything screwed in place, it's time to add a back panel. For this step I moved the whole construction onto a flat surface. A large sheet of 12mm MDF was then put against the back side and held in place with a few clamps. On the right side, I roughly marked out the excess material, which I've cut off with a handsaw. The left side of the back panel was aligned with the cabinet and clamped again in position. Next, I used a pencil to mark all the contours of the shelves. This way I know exactly where I can add the screw holes. A large nail is used to punch a center mark, and then I drill out all the pilot holes. The back panel is turned over, and again the rough exit holes are treated with a countersink bit. Once again I add the back panel to the cabinet, this time to pre-drill each hole into the sides and shelves. And once again I remove the back panel and clean out any dust with a vacuum cleaner. The same is done on the back panel as well. Next, it's time to add the wood glue to the back. This needs to be done quite fast and precise. The back panel is then carefully positioned against the cabinet and clamped up again. Screwing things together goes easy now, as the screws find their way into the pre-drilled holes. And with the back panel installed, the cabinet has turned into a sturdy construction. Each shelf also received about 3 screws. The top and right side of the back panel was roughly cut with some excess material, so that excess is now removed with a flush trim router bit. You can avoid this step by cutting the back panel to its final size before screwing it in place. Next, it's time to sand everything. Like most people, I hate sanding, but it's a necessary step, so we just have to deal with it. The front side needs some extra care. For this I glued some sandpaper to a piece of wood, so the surface will remain flat. The sharp edges of the MDF are easily damaged, so I decided to round them off with a round over bit. It makes the edges less brittle and has a decorative effect as well. At the corners, the router bit might hit the metal screws, so I temporarily removed them. Added the round over, sanded the surface, and then put the screws back in place. The edge of each shelf received very light sanding to remove any sharp corners. If you don't cut your finger, it should be fine. I made these grooves on both sides for the electric wiring, but there is not yet an opening for the wire to enter, so this will be added at the bottom right here. I added a few lines with a pencil and used a fine saw blade to extend the groove. A small tool like this chisel can then be used to remove the material. The next thing is a bit overkill. I decided to add a metal corner bracket on both sides, which I needed to carve out with a router bit and chisel out. I don't recommend doing this as it will hardly add any strain to the cabinet, so yeah, you can just ignore it. Let us now focus on those ugly screw holes inside the cabinet. I start by cleaning out any dust with a vacuum cleaner. Then I used an MDF filler, but any wood filler will work fine. I put some filler onto a putty knife and then smear it into the screw hole. Take off the excess and let it dry. When dry, use a palette knife to scrape off any rough texture. Then use a block of sandpaper to flatten the surface. And clean off any dust and repeat these steps until you have a perfect finish. Let's talk about the lighting. I will use self-adhesive LED strips to light the shelves. But I don't just want to stick them to a shelf like this. I want them to shine onto the model, and also I don't want to see them in the first place. So to achieve all that, I will add these wooden corner profiles. I've cut them down into 8 pieces, one for each shelf. Then I turned the whole cabinet upside down, so I can easily glue all the profiles in place with wood glue. Aligning the wood with the front of the MDF will always result in an ugly seam line over time. So an old trick is to move them slightly back. In this case I'm using a 2mm piece of plastic. I added some light pressure with small plastic clamps. Next I will be adding these triangular profiles, which I glued in place with wood glue. So the first profile is decorative and will hide the LED strip from sight. The second one has a 45-degree angle and will point the light better onto the models. This idea should work fine for the smaller shelves, but not so much for the larger compartment on the right side. So for that shelf I decided to make a custom profile from a piece of scrap wood. I changed the angle of the saw blade and carefully did a few cuts until I had only a thin strip of wood left with the right angle. Next I glued the strip in place with wood glue and pressed it down with my fingers. With all those profiles in place, it's time to drill some holes into the side so we can later connect the power cables to the LED lighting. These should arrive in or close to the groove we made before. The MDF fibers are a bit fuzzy, so I used a router bit to make the holes look a bit cleaner. You can also use the tip of a large drill bit or even make a few cuts with a knife. At the top of the cabinet, a small piece of wire will run through the middle wall to power the right side. I made the mistake of drilling that hole at the wrong place before construction, so now I had to fill it up with a piece of dowel and finished it off with some filler. If you have some experience with caulking, then you can, as an optional step, add some wood glue or caulking product to improve the look of the seams. You can also make it look worse with this step, so only go for it if you know what you're doing. And with that, the main construction of the cabinet is done and ready for the next step. Before we start painting, I clean the whole project with a vacuum cleaner. I start with a white primer. This one is water-based. For the first layer, I will be using a simple brush and paint roller. It's a good idea to start with a brush, because the brush can be used for all the spots that will be hard to reach with a paint roller, like corners and those profiles I added for the lighting setup. For the larger surfaces, I switched to a paint roller. I prefer this type because it can carry a larger amount of paint. I dropped some paint into the tray and we're ready to roll. A paint roller is usually very easy to use. In this case, however, it's quite a pain to work inside all the small compartments, because you have to work more precisely and the progress is very slow. So after the first coat, the result looks like something which was painted in kindergarten, but this will be fixed when a second coat is applied. But before we can apply a second coat, we need to sand everything smooth again, because the first layer of primer will pull all the loose fibers of the MDF to the surface, making the edges feel rough. All that sanding produces a lot of superfine dust, so once again I reached for my vacuum cleaner. Okay, so for the second coat I wanted to try something different. Yes, it's one of those very cheap airbrushes, and by calling it an airbrush, some people are probably already smashing the dislike button. But I must be honest, I still use it sometimes with lacquer paint to restore tools and some small items like this German ammo box, for example. So I hooked it up to an air compressor and prepared the cabinet for a second coat of primer. I thinned the primer with water in a plastic bottle and gave it a good shake. You should wear a respirator with a carbon filter when spraying paint. That said, I didn't have any more cartridges, so I've cut the old ones open and placed pieces of kitchen hood filter inside. This will catch the larger particles but not the microscopic ones, nor any vapors. So don't be like me and get the right equipment. So masks on and let's give it a try. Well, it did work to some extent, but this water-based stuff just clogged up so much more than lacquer paint, it was a real pain to work with, so I switched to plan B, a normal paint gun. So why on earth didn't I start with this one in the first place? Well, the main reason is the enormous overspray this gun produces, followed by a noisy compressor that, due to the high airflow, no longer shuts off. I slowly built up the surface with light coats to avoid any paint runners. When dry, I did more sanding on the edges to get a better surface finish. The next day, I sprayed another coat of primer with the paint gun. By now, the surface was pretty smooth and ready for the next step. For the final finish, I used a water-based lacquer and switched to a more soft, flat brush. It's a warm, light grey tinge which will match the color of the wall. So once again, I painted all the corners and hard-to-reach surfaces with a brush. And then switched to a paint roller to cover the larger, flat areas. This type of paint covers much better than the white primer, so only one coat was needed. There was still a small difference in glossiness between the brush and paint roller surfaces, so a very light coat was still added with a spray gun to even that out. And make sure to clean the top of the paint jar between coats, so you don't get a buildup which might fall into the paint and ruin your work. Okay, so now the paintwork is all done. Next I'll take a look how you can add LED lighting. I found this cheap set at a local hardware store. It contains a 5-meter LED light strip which can be cut to size, a 12-volt DC power supply, and even a dimmer with remote control, which I find a bit too fancy, so I won't be using it. Instead, I'm adding a small power socket and some extra wire. The plan is to cut the LED strip, divide it over 8 shells, and make new connections. Each LED strip is different. This one has cutting marks after every third LED. and also visible copper connection pins. Looking at these marks, I was able to cut my 5-meter strip into 8 pieces of 60 cm. The cut is carefully made without damaging the copper contacts. When all pieces are cut down to length, I need to gain access to these connection pins. In order to get to them, I need to remove some material. This is tricky because if you cut too deep, you will damage the circuit board conductors, so take it slow. I cut about 90% and removed the last bit with a sprue cutter. This is a bit of a pain, but if done right, the copper contacts are now ready to use. The lighting strips at the top are a bit special, because these are interconnected in the middle. So let's start with that first. Turning the cabinet upside down again will make the work easier. I lay down both strips in front of the cabinet and center them. Next, I measure how long the wires need to be to connect the strips. Most LED strips consume only a small current, so you can use all sorts of wire. I would recommend using a cable with a similar size as used on your 12-volt power source. For example, perhaps a cable from an adapter you don't use anymore. Next, I cut the wire at the right length. I separate the ends a little bit and remove the insulation without damaging the copper. I like to twist the small copper wires into one solid piece, but clean your fingers with alcohol so you don't add any sweat or grease to the connection. Next, I touch some solder to the tip of the iron, and then add more solder to both ends of the copper wires. This wire will connect both LED strips, so the copper pads receive some solder as well. These copper pads are very fragile, so you need to work fast to prevent heat from building up. The second wire is connected as well, and then I use a small amount of hot glue to seal the connection. So both strips have a wire at the ends which goes through the outer walls. This strip has the wire for the wall in the middle, so that wire is fed through the hole, and then inside the cabinet the final connection is made. From here on it's very important to make the right connection each time, positive to positive and negative to negative. The connection is sealed with hot glue again, and when everything looks okay, I peel off the backing paper from the LED strip and carefully stick it in place onto the angled profile. All the other shelves receive an LED strip as well. These only have a wire on one side and are fed through the holes in the sidewall. When all the strips are in place, I need to connect them. For this I use a slightly thicker wire with a black and red color. I marked every hole onto the cable and then removed the insulator at those marks. To do this, I used a sharp blade and carefully removed the outside without damaging the copper. Then I added more solder to the copper with a soldering iron. I place heat shrink tubes onto the wires, make the connection with the soldering iron, fit the shrink tubes over the connection, and carefully heat them up with a paint stripper so they shrink and seal the connection. When all the connections are made, I now need to work the cable inside the slot. The 7mm groove I made turned out to be on the small side, so make sure it's wide enough for your needs. An easy way to keep the cable inside the slot is to use hot glue. But to make it removable as well, I add a small piece of tape on top of the cable. With the dull side of the blade, I push it all the way back, and then a small amount of hot glue is added, which can be cut loose again if ever needed. But we still have to connect the whole light setup with the 12-volt power source. For this I will be using a small power socket. This one is actually designed for circuit boards. I drew the shape onto the bottom of the cabinet and used a Dremel tool to remove the MDF material. And so it will be installed like this. To make sure you are using the right connection pins of the power socket, you can use a cheap multimeter. Switch it to the resistance scale or something similar, and in the perfect world, when both test leads connect with each other, you would read something like 0 resistance. You can then use that to check which pin is connected to the sleeve and which one with the tip. If the power source doesn't have any label on it, you can switch the multimeter to the DC voltage scale. Connect the test leads to the jack with the adapter plugged in. As an example, I place the black lead inside the tip and the red one onto the sleeve. I measure a negative 12 volt, which means I am holding the test leads inverted, which is incorrect. So I switch the red lead inside the tip and place the black one onto the sleeve. Now the minus sign is gone, so I'm holding the test leads correctly. So now we know that the tip needs to be positive and the sleeve negative. With that info, we can now add more heat shrinking tube and attach the red wire to the pin of the tip and the black to the pin of the sleeve. Okay, so now would be a great time to find out if this whole thing actually works. So 3, 2, 1. Whew, just imagine the pain if it didn't. After the test I added more hot glue to the socket to keep it firmly in place, and with that all the electric stuff is finally done. So next the construction needs to be mounted to the wall. I decided to screw this piece of aluminum to the wall first. This will add support to the underside of the cabinet and make the installation easier. You can cut the aluminum with most wood tools, or use a metal saw or grinding disc. Afterwards I cleaned the edges with a flat file. Next I marked 5 screw holes onto the profile and drilled them out with a small drill bit. These holes were then countersunk with a countersink drill bit. The profile was then turned 90 degrees on its side and 5 more holes were added with a larger 8mm drill bit. So the plan is to use these larger lag bolts to screw the profile to the wall. Then let the weight of the cabinet rest on top of it and add some small screws to keep it from sliding off. The cabinet turned out to be too large for the staircase, so it was a struggle to drag it to the first floor, but luckily it arrived in one piece. Next I quickly cleared my workspace. I took away some older models and the Spitfire had to go too. Finally I removed my desk lighting and we can get to work. A few years ago I insulated this wall myself, so I know exactly how it's built up. I made a wooden frame and filled it up with rock wool panels. The frame was covered with OSB and finished with a drywall. Those OSB panels now provided me with a strong base to screw things in position. And if you have a brick wall, then I would suggest using nail plugs or something similar. I first used a magnet to locate the drywall screws, as the drywall was also screwed into the OSB. The correct height for the aluminum profile was determined, and I drilled a pilot hole for the first lag screw through the drywall and the OSB. The lag screw in the center is then screwed to the wall to hold the aluminum in place. Next, a level is put on top of the profile so the angle can be corrected. The 4 remaining bolts are then also pre-drilled and screwed in place. The aluminum profile keeps the lower shelves clear from ugly bolts visible in the back side. But for the top I didn't want to take any risk, so I'm placing 3 bolts in the left side, which can easily be hidden with some scale models, and 2 on the right side, slightly harder to hide though. I carefully marked the holes and drilled them out with a drill bit used for the lag bolt pilot holes. On the left side the cabinet is put against the wall, so I added a small weather strip to make up for any imperfections in the wall. Then it's finally time to hang the cabinet against the wall. The construction was placed onto the aluminum support, and some extra hands then held it in place while I drilled the pilot holes into the drywall and OSB. Next, a larger 8mm drill bit is used to widen the holes in the MDF. So the lag bolts can be inserted and then tightened with a socket wrench. And just to be safe, I added the last small screws into the bottom. Now that the cabinet hangs to the wall, it's time for the final step, adding the sliding glass doors. To keep things simple, I will be using 2 aluminum profiles that I found at a local hardware store. I start by cutting them down to size. For this you can also use a metal saw or grinding disc. The edges were cleaned up with a small file and some fine sandpaper. The top profile will receive some small screw holes, so I punched a few center marks with a nail and hammer so the drill won't be sliding all over the place. Then a small drill bit was used to add the screw holes. Next I cleaned up the rough exit holes with the tip of a larger drill bit. The problem with these profiles is that they are so thin that there's hardly any material left to add a decent countersink for the screw. As a result, I won't be able to make the head of the screw flush with the surface, so screws can only be used on the top profile and not the bottom one. The tip of a 5mm drill bit was used to countersink the holes as far as possible. But as you can see, this still wouldn't be deep enough for the bottom profile. I also drilled the holes alternate into the left and right slot. Next I put the top profile in place and used a pointy object to mark the holes of the profile onto the cabinet. A Dremel tool with a small drill bit was then used to pre-drill the screw holes, and the top profile is screwed in place with a small screwdriver. For the bottom profile, I decided to use an epoxy adhesive, so the glass doors can slide freely without touching any screws. It's a good idea to roughen up the smooth aluminum surface. I added some light cuts with a box cutter so the glue has something to grip onto. Next, I put the two components onto a piece of plastic and mixed them together with a toothpick. Then I had about 5 minutes to add the glue to the profile and glue it in place onto the bottom side of the cabinet. With the aluminum profiles mounted in place, we now can determine the final dimensions of the sliding glass panels. The ideal thickness for the glass in my case seems to be 5mm. This will allow some play to easily slide the panels back and forth. For the width, I measured between the inside of the outer wall and over the full thickness of the middle wall. For the height, I measured the inside of the aluminum profile at the bottom, added the height between the bottom and the top profile, and another 6mm inside the top profile, which creates a clearance of 3mm above the glass, necessary for smooth sliding and to avoid touching any screws. I also like to install a small handle onto each panel, so for this a small screw hole needs to be added into the glass as well. Next, I used the measurements to make a drawing for the glass doors. You can order many different types of glass for a project like this. The cheapest solution is standard float glass. However, this is also the most fragile option, and when it breaks it will fall apart into large, sharp pieces which might cause some serious injuries. As an alternative, you can order laminated glass, which consists of a thin plastic foil pressed between two layers of glass. On impact, the plastic foil will keep all the shattered pieces together. I couldn't find a panel of laminated glass as thin as 5mm, so I ordered tempered glass. This type of glass is heated into an oven at about 600 degrees Celsius and then quickly cooled down, which makes it about 4 times stronger than standard glass, and on impact it will crumble into small pebbles. Important to know about tempered glass is that all operations like cutting and drilling need to be done before the glass gets heat treated. So I made an order at a local glass company, picked it up about 2 weeks later, and could now finally finish the project. I first unscrewed the aluminum profile at the top. Next, I added Vaseline to the bottom side of the panel to reduce friction. And then both panels were carefully put into the bottom profile. The top profile is then placed on top of the glass and screwed back in place. Soft plastic was used to create a protective spacer for the handles. I then installed a small handle on each panel, which will be held in place with one screw. Well, this project was on my to-do list for so many years, so I'm really excited to see it finally finished. I placed a few models inside, but of course the contents will change over time as new models will replace the older ones. I hope this video can help some people out with their own project, and if not, then I hope it was at least fun to watch. Many thanks for watching, keep it safe, and I hope to see you on the next one.